I'll get you started anyway. I might get you to do question 5A.
Okay.
Okay. And then I'll get you to do 6ABC. Oh no, 6B. Okay.
Mm-hmm.
And then I'll get you to do 7A and B. Okay. That'll keep you busy.
Sounds good.
Okay. And then I'll have a look for your scope and sequence because I'm pretty sure you guys gave it to me.
Mm-hmm.
I know, just can't find it. Okay, so I'll just write it here actually. Question 5A, 6B, and I'll go through these in a moment as well.
Okay.
Question 7. Now, question 7 is really important. And it'll be important later on. It's A and B. Okay, so have a go at those 3 questions, and then I'm going to have a look for the thingo for you. Okay.
Okay. Thank you.
Oh, Jackson.
Yes.
Yeah. You did give me the scope and sequence, right? But that's not the one I'm after because you gave me the year 11 one.
Oh, did I? Okay.
Yeah. So I wanted I'm looking for the year 12 one.
Okay. I'll have a look. I may have it back here in my email.
Hang on, I'm just going to see if Cameron's got one. That he might have given me.
No, nothing from me.
Okay. Can you follow up and get it from your teacher?
Sure. Yeah,
Okay,
sorry.
that would be awesome.
All good.
Now, how are you finding online, the lessons being online?
School or here?
Well, both. Both.
Okay. I'm liking these ones. These are
Yeah.
good. I'm finding school interesting.
Yeah.
But yeah.
Okay. So what do you like about these ones?
Um, I'm not sure it just works really well.
Okay.
And I can still sort of ask questions and understand the concepts.
Oh, okay.
The school, the teachers, for me at least, are more just like, here's the work, go do it.
Oh, okay.
Yeah.
Right. So there's no kind of teaching element to it. It's more kind of like telling you what to do.
Yeah, pretty much.
Okay. So I'm going to give you 3 minutes to do that, and then I'm going to go through some of these.
Okay.
But once you're done, what I'd like for you guys to do is take a photo on your phone and send it to the group chat. Okay?
Okay. I'm just went back and started on that first one after looking for the scope and sequence. It gives you sine x and cosine y,
Yep.
but it doesn't give you cosine x and sine y. Obviously, you've got to solve for that. But
Sorry, say that again.
so there's sine x. It says when sine x and cosine y equal 2/3 and 3/4.
Yeah.
3/4.
Yeah.
What's sine x plus y? And when you expand that.
Okay, so you got to expand it. Use the compound angle formula to expand it.
So I've got it expanded.
Uh-huh. And so your question now is what? I think I can pretty much preempt your question, but I want you to ask it.
Okay. Well, the second half is cosine x sine y.
Yes. So your question is?
Is how do I solve for those and find those?
Yes. In particular, cosine x, right?
Yes.
How do I find cosine x? Right. So draw a right angle triangle.
Oh, we're doing, yeah. Okay. That makes,
Do you remember?
yeah. It's just the formula sheet triangles, is it?
Yeah.
Yeah. Okay.
Now I don't know why this isn't opening. I'm just going to click the heck out of it and see what happens. So, oh, I see where it, now I've seen everything. That's where it is. It's hiding behind. It's hiding behind Bingo. Okay, cool. So let me just put that over there. And let me put this over here. Got it. Okay, so I'll start you off. I'll give you a hint.
Mm-hmm.
Oh, there we go. Okay. Let's get rid of all of that. Move that down there.
And
Move that over to the side. Cool. So you've got, what was it? Sine x plus y.
yes.
That expands to?
Sine x cosine y plus cosine x sine y.
Plus cosine x sine y. Good. Right. So we know that sine x is equal to 2/3. Yep.
Yes.
Is that right? Yep. So cosine x is going to be equal to, now, what that's going to be equal to will depend on the right angle triangle. So that's going to be x, right? And it's going to be in the ratio 2 to 3 opposite over hypotenuse. Yep.
Mm-hmm.
So
Yes.
the adjacent's going to be root
Root 2? No. Three, 2, and I know that there's the root 3, the 2, and the 1.
Root 5?
Yeah, how do you get root 5, Cameron? You're right. But how do
3
you get
squared is 9 minus 2 squared, which is 4, is 5.
Oh, right.
Yep, and then you square root that, right? Pythagoras theorem, right?
Mm-hmm.
Yeah, Jackson, you okay with that?
Yeah. That makes sense now. So.
Yeah, root 5 on 3.
Mm-hmm.
And then you've got sine y and cosine y. Now, we know what cosine y is. It's 3 over 4. Yep.
Yeah.
So what would sine y be?
Would it be...
Now,
would
3 would be the what side?
So the 3 would be the adjacent.
Yeah, so 3 goes here. So the opposite side would be?
The opposite side would be the 4. No, root 7.
Root 7, good. Okay, so what would sine y be?
Be root 7 on 4.
Yes, got it?
Yep.
Okay, so then you've got sine x plus y becomes
Oh, yeah.
2 over 3.
Mm-hmm.
Right, times,
Mm-hmm.
yep,
3/4.
3 over 4 plus
Root 7 on 4.
cosine x,
Oh, sorry, root 5 on 3.
root 5 on 3 times
Root 7 on 4.
root 7 on 4, good.
Mm-hmm.
Okay, which then makes it, what's that, 6 on 12
Mm-hmm.
plus, that's a 7.
Sorry? Yep.
That's a 7.
It's 7.
Yep.
Oh, yep. Right.
So what would this become?
Be root 5, root 7. Oh, but I can't do that yet. I've got to multiply down.
Yep, so what would that be?
Doing fractions. So the top would be something root 7, root 5. But I'm just working on what that is.
What's root 7 times root 5?
Or root 35?
Yep.
Okay.
Okay. 3 times 4?
Oh, right, yeah. Sorry. That makes more sense. 12.
Okay, so our answer is going to be?
On 12, right.
Got it?
Yep.
Okay, cool. So what I want you guys to do now, Cameron, have you got that?
Kind of.
Okay. Where are you, which part of this is causing you to not get it 100%?
Oh, the second line on the right. Yeah,
Yep.
I accidentally forgot. I was doing sine 3 on 2, cos 3 on 4, rather than just 3 on 2 and 3 on 4.
3 on. So you're using these values, were you?
Yeah, except I was putting sines and coses
The other way
before them
around?
for some reason.
Actually, I think you're right. So, hold on. Sine Y. No. No. The way Jackson's done it's okay. Yeah. So what did you have on the top line, Cameron?
the very top line, I had that same formula.
Oh, okay.
And then
In the second line,
I had sine 3 on 2 times cos 3 on 4 plus.
oh, okay. Right. So you had, so yes, okay. So this is the value for sine x.
Yeah.
Yeah. Yeah, I see what you're saying. So when you've got sine of x equals to something else, let's call it A, right? Your x is your angle
Yeah.
and your A is your ratio. Okay? Oops. Okay? So that's what we call a ratio. Hold on. Yeah. Oh, that's your angle. Got it? So if you've got an angle, the sine of an angle gives you a ratio.
Yeah.
Yep. So you just got to make sure, right, that when you've got your 6 on 12 or your 2 on 3, that's going to be a ratio. So you don't put your ratio as a sign. You don't put sine of a ratio because that's not how you do it.
Yeah.
Okay? You've always got to do sine of an angle. Yeah. Can I get you guys to do B?
Sure.
Yeah.
X minus 1.
And when you're done, just take a photo and upload it to the Facebook group, yeah?
Sure. Yeah, just sent it through. What I think I got.
Okay. Let me open it up. And what about you, Cameron? How
I've sent it as well.
you sent yours as well?
Yeah.
Let's compare the pair. Right? Sounds like an ad. Okay. So we'll start with this one. So whose is this?
That's me.
Jackson. Okay, cool. So let's so control plus. Oh, actually, I'll save it as an image. Save image. And we'll call it Jackson's response. Yep. And then we'll do the same thing for Cameron. And we'll call it Cameron's response. Shoot. Okie dokie. And then we'll open it up, yeah?
Okay.
Yep. Okay. And then we'll close that. And then basically rotate that. Okay, so we'll start with Cameron first. Whoops. And then we might actually zoom in. Okay, so we're doing cosine x minus y. We've got cosine x, cosine y, sine x, sine y. I think a plus. Cameron?
Yeah. I thought you change it because there's a cos x minus y.
Yeah,
you
you
change that to a minus, but
You do change it, but in the cos formula, it has a negative to start with.
oh, does it?
Yeah.
Yeah, so Cameron?
Oh,
So you got cosine x, y, minus y, right? With the cosines, it's the opposite sign. So if that's a minus, it becomes a plus.
yeah.
Okay? Just be aware of that. Otherwise, it looks okay, right? So let's go back to the question. So hang on. Cameron, did you get this?
Yeah.
Okay? So it's a plus.
Yeah.
Okay? Now, if we go back, so this question there is cosine x minus y, and you've got 2/3. Yes, 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 and yes, and that should be a plus. That's the only thing.
Yeah.
All right, well done. Well done. So Cameron, you get almost full marks.
Yeah.
Let's move this down. Jackson,
Yes.
we'll make this bigger. So that was something that we can see. I think so. Yes, 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 yes. No, 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 no. Okay, so you were right up until there.
Mm-hmm.
Okay, and then I think we might need to do some work on surds.
Yeah, I went to root 9, root 5 for that first one.
Yep, that is correct.
Which then I
And
multiplied.
add the surds.
I multiplied them. 9 times 5 is 45.
No, 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 but you can't add these ones to get 73.
Oh, you can't. Okay.
No,
Right, yeah.
you can't. But the other thing I was going to say is that's not wrong, but that's more simplified than that.
Yeah, okay, that makes sense.
Okay, so just leave, you leave your answer in that form.
Okay.
Okay?
Sounds good.
Okay, otherwise not too bad. All right. Cool. Now, can I get you to do question 6 then? Instead of using the compound angle formula, use the double angle formula.
Mm-hmm.
All right, so 6B.
Six B or 6C, sorry.
6B. Yep.
Okay.
Okay. Welcome, Artie.
Hey, Seung.
Welcome, Nicholas.
Hi, Seung.
We're doing 6B, this one here. We've just done these two. Okay.
So my A and B values are both 20?
Theta. Yes.
Theta. Yep.
Yep.
Seung, I had a question from a different textbook. But
Okay, can you upload it to the group chat for extension 1 and I'll deal with it.
Okay.
Yeah.
Up the top of, hang on. Oh, okay, don't worry.
And then you may as well do, what I wouldn't mind you doing is A, B, and C, actually.
Mm-hmm. Sorry, which A and B, A, B, and C song? Question
Sorry,
6?
question 6.
Yeah, okay. Thank you.
Okay, yep. And once you're done, just let me know.
Okay, thank you.
And Artie, have you sent the question through?
Yep.
Okay, let me just have a look.
Okay.
Okay. Okay, well, let's go through that one after we've done the questions that I want to go through. You guys done? Shouldn't take you too long.
Just figuring out the last one.
Okay. Okay, these should come off the top of your head.
The 2 thetas are freaking me out a little bit. I'm just
Okay.
Yeah.
Whoops. So let me do the first one for you. Okay. Okay, so you've got sine 2 theta is basically equal to sine theta plus theta, isn't it? Okay, so you should have sine theta cos theta plus cos theta sine theta. Okay? A, B. Got it? So you should end up 2 sine theta cosine theta. All good?
Yep.
Okay. Cosine 2 theta. All right, how are we going there?
Fine.
Cosine theta, cosine theta, minus sine theta, sine theta. You okay with that?
Mm-hmm.
You sure?
Yeah, no, that makes more sense. I know what I did wrong.
Okay, what'd you do wrong?
For some reason I went to the cos A cos B.
Yeah, that's what you do, right?
Okay.
But A equals to
Theta.
B equals to
Theta.
theta. Okay.
Mm-hmm.
And so you get cos A, cos B minus sine A, sine B.
Oh, okay. Yep.
Got it? So
Yep.
it's cosine squared theta
Mm-hmm.
minus
Sine squared theta.
yes. Got it?
Mm-hmm.
Cool.
I've done all the ones you've told.
Okay. Now, there's two other forms of this, right? Now, you need to know these as well.
I think I know them.
You should just roll off your, these should really, you should like roll off your, you know, it should be part of your repertoire. Do you know what I mean? So the other one is 2 cos squared theta minus 1. And then 1 minus 2 sine squared theta. Okay? So these three should be part of your repertoire, right? Cosine 2 theta is equal to each one of those. Now, how do I get that? Any ideas?
Yeah.
Yep. Artie?
We use the rule sine squared plus cos squared equals 1.
Yeah, sine squared theta plus cos squared theta equals to 1. Yep.
So then for the first one,
Yep.
we'd have to do cos squared theta minus 1 minus cos squared theta.
So, sorry, wouldn't it, yeah, so wouldn't it be sine squared theta equals to 1 minus cos squared theta? Is that what?
Yep, I just substituted it into the cos 2 theta
Yeah.
equation.
So then you take this, substitute it into there, because they're both equal to sine squared theta, right?
Mm-hmm.
And you should get cos squared theta minus 1 minus cos squared theta. Yep.
Yep.
Which equals to cos squared theta minus 1 plus cos squared theta.
Yep.
Gives you that. Yep.
Mm-hmm.
Good. And then if you rearrange that again, you should get cos squared theta equals to
1 minus sine squared theta.
1 minus sine squared theta. Yep. So then you substitute into there, right? Into there, and you get 1 minus sine squared theta minus sine squared theta.
And that gives the other one.
It gives you, yeah. And there we go. And that gives you that one there. Got it?
Yep.
Cameron and Jackson, does that make sense?
Yep.
Yeah, that makes a lot of sense.
Okay, so just, you need to have this in your repertoire. Okay, so just copy that down somewhere. Okay. These you use all the time in extension 1. Okay, especially when we do integration and differentiation. So I would suggest you just get used to these ones. Okay.
Mm-hmm.
Yeah. Can I delete this?
1 second.
Oh, okay. Hang on. Hold on. Let me know.
Yeah, I'm all good now. Thank you.
Okay, cool. Because the next one we're going to do, I need a fair bit of space for the next one. But the next one we're going to do is sine 3 theta. Okay, I'm going to do sine 3 theta, and then you're going to do cosine 3 theta.
I've already done both.
Okay, cool. So Artie, you can talk us through it.
Okay.
Okay, hold on. Let me just rub this out. I'll use the blue. So you've got, what is it? Cosine 2 theta is equal to, what is it? 1 minus cosine squared theta minus sine squared theta. 2 cosine squared theta minus 1. And then it's also equal to 1 minus 2 sine squared theta. And then you've also got sine 2 theta, which is equal to 2 sine theta cosine theta, right? And the question that I'm going to ask you guys is write sine 3 theta in terms of sine theta. Okay. All right. So sine 3 theta. Artie, take it away.
So first we make it equal to sine 2 theta plus theta.
Yep.
And then we just use the sine A plus B formula.
Yep. So talk me through it.
So it'd be sine 2 theta cos theta plus cos 2 theta sine theta.
Yep.
And then because
Keep
sine
going.
2 theta has a double angle formula, we substitute that in for sine 2 theta.
Yep. So 2
Sine theta cos theta.
theta cos theta.
And then that's all multiplied by cos theta. And then we
Yep.
plus that by the double angle cos
Okay.
2 theta.
So I'm going to use the
sine one.
yeah.
And then that all multiplies by sine theta.
Okay, hold on. Let me just stop there. Okay, does everyone understand what I did from there to there?
Yeah.
Yes?
Yep. Sorry, working out
Yep.
my.
Yep. Cameron,
Yeah.
does everyone understand what I've done from there to there?
Mm-hmm.
No.
Okay, so I've used the compound angle for formula for sine, right? Compound angle for formula for sine looks like this. I'll write it over here. Sine A plus B equals to sine A cos B plus sine B cosine A. Got it?
Yeah.
So what I've done is that's your A, that's your B. Okay? So sine A, cosine B, cosine A, sine B.
Why is the cos squared though?
It's not. It's not. That should be.
Oh, it's a 2 theta.
Yeah.
Okay.
That's my ugly writing. Got it?
Yeah.
Okay, so that makes sense?
Yeah.
Okay, so tick. Does everyone understand how I went from there to there?
Yeah.
Okay. Cameron?
Um,
From there to there.
yeah. Yeah.
Okay, cool. All I really did was substitute that in there for the sine 2 theta.
Yeah.
That in there for this one here. Got it?
Yeah.
Okay, cool. So we're all good there. So then what we do, Artie, take it away.
So then the first one will become 2 sine theta cos squared theta. And the other one will be sine theta minus 2 sine cube theta.
Does everyone understand?
Mm-hmm.
Yep.
Yeah.
Cameron?
Yeah.
Okay. And then what do we do? Artie, take it away.
Then we convert the cos squared theta to 1 minus sine squared theta.
Yes.
So then we have all in terms of sine.
Yes. And so what does this become in terms of sine thetas?
1 minus sine squared theta.
Yep. Yep.
And to expand that, it would become 2 sine theta minus 2 sine cubed theta, and then the rest. And then putting that all together, it'd
Yep.
be 3 sine theta minus 4 sine cubed theta.
Yeah. Good. Got it? Every-
Mm-hmm.
All right. Nicholas, do you remember doing this?
Yeah, I do.
Yeah. Jackson, does this make sense?
Yeah, no, that's all okay now.
Okay. Cameron,
Yeah.
does that make sense?
Yeah.
Okay, good. Now, this is super important when it comes to integration of trigonometric functions. Okay, so you need to be able to go from there to there quite fluently. Got it?
Mm-hmm.
Okay, and you've also got to do the same thing for cosine 3 theta in terms of cosine theta. So can I get you guys to give that one a go?
Sure.
Yep.
I've done it.
Yep, you've done it?
Yeah.
Cool. So you other guys, can you give that a go, please?
Sure.
Okay, give that a go. And then Artie, I might go through your question while the others are doing that, yeah?
Okay.
Okay, so what I might do is I'll share a whiteboard, and then whoa, what have I done? Share the whiteboard. Oh, there we go.
It was mostly B and C that I had confusion with.
Okay. All right. So then it says find the inverse function in terms of y given that x equals f of x equals to x plus e of x. Is that right?
Yeah.
Okay, so then let's have a think about how we might do this. So inverse function. So we've got basically x equals to inverse f of x plus e to the inverse f of x, right?
Mm-hmm.
Let's have a look. How would you do this?
We usually just swap the x's with y's.
Yeah.
And it says in terms of y, so I just left it at that.
Yeah. So well, let's do it that way. So y equals to x plus e of x. So f minus 1 of x becomes x equals to y plus e of y. Got it?
Mm-hmm.
So then you've got x minus y equals to e of y.
I've checked the answers. It just goes up to y plus e to the y.
Y plus e to the y. Oh, it's just. Oh, okay. So it's just that, is it?
Yeah.
Okay. Yeah, because it's hard to actually make y the subject of the formula.
Yeah.
Yeah. And then the question says find the image P on the inverse function of the point where f of 1 equals to e to the 1. Okay, cool. So so this is part B, right?
Yeah.
So when f of 1 equals to 1 plus e, x equals to 1, y equals to
1 plus e.
1 plus e. So P will be the other way around.
Okay.
Y equals to 1, x equals to 1 plus e. Got it?
Right.
Yep.
Yep.
Does that make sense?
Yeah.
And then C, find the equation of the tangent to f dash at P. All right, so let's have a look. So if you've got, there's a couple of ways to do this. So now, if f of x equals to x plus e to the x, f dash of x is equal to 1 plus
E to the x.
Good. So the inverse function of x, the derivative of the inverse function of x will be
1 plus e to the y.
No.
Oh, right.
Be
1 over, right.
Yep, over e to the x. Does that make sense? Why that is?
Um,
I'll explain. Okay, so f dash of x is going to be equal to dy dx.
Mm-hmm.
Got it?
Yep.
Now, f of minus 1 x, the derivative of that is going to be dx dy.
Right.
Now, the reason why that is if y equals to the function of x, right, the inverse function would be x equals to the function of y.
Mm.
Got it?
Yep.
So the derivative of that equals to dx dy.
Right.
Got it?
Yep.
Which is going to be the inverse of f of x.
Okay.
Got it?
Yeah.
So that's why it's going to be the reciprocal, the derivative. It's going to be the reciprocal of the derivative.
So why don't we use the derivative of y plus e to the y?
The derivative of y plus e to the y.
Yeah.
You can. And we'll check both. Okay. So
Okay.
the gradient of this tangent is going to be 1 over 1 plus e to the x if we use 1 over f dash of x.
Yep.
Another way that we can find the gradient is basically, what is it? 1 plus e to the y if we use the derivative of the inverse function.
Yeah.
Got it? Okay, now, what does x equal to in this situation?
1 plus e.
1 plus e. So we're going to put this over, so it's going to equal to 1 over 1 plus e to the 1 plus e. Got it?
Yep.
Or we are going to go m equals to, what is it? 1 plus e to the
1.
Right. Cool. I think what you'll find is that they're both going to equal the same thing. I can't see an easy way of how we do that. So what's that? How do we do that?
I can see that it'll be 1 plus e to the negative 1 plus e. Like using index
use
laws.
this one. Probably easier to use this one.
Yeah.
Got it?
Okay.
Oh, hang on. Sorry. Hold on. Wait. Where's the rubber? So if oh no, that's right. So if hold on. So if f of x is equal to y plus e to the y, right? F dash of x is going to be 1 plus e to the y. Yep.
Yep.
Which is going to be 1 plus e to the 1.
Yep.
Yep. So then to find the tangent, we're going to use y minus y1 equals to m outside of x minus x1.
Yep.
And then x is equal to 1 plus e, or x1 is equal to 1 plus e. y1 is equal to 1. And m is equal to 1 plus e to the 1.
Yep.
Got it?
Yeah.
So then you've got y minus 1 equals to 1 plus e, x minus 1 plus e. Got it?
Isn't it x minus 1 minus e?
Like that. Yeah, that's right. So you got 1 y minus 1 equals to 1 plus e, x minus 1 plus e squared,
Right.
y equals to 1 plus e to the x minus, and then it's going to be, let's just expand it out, 1 plus 2e plus e squared plus 1, okay?
Yep.
Which means you've got y equals to 1 plus e to the x. Okay, and then that 1 and that 1 are going to cancel.
Yep.
Minus 2, minus e, 2 plus e squared.
Isn't it just 2 plus e?
Yeah, 2 plus e. That's right. Got it?
Yeah.
Is that the answer?
I can check that.
Yeah, just check it.
Because the way I remember it, I remember the 1 plus e there being there.
Yep.
The 2 plus e is different though.
Just check the answer.
Yep.
Now, Cameron and Jackson,
Yes.
Yes.
you got answers?
No.
I do, but I'm almost positive it's not the right answer.
Okay, what did you guys get?
I managed to cancel everything out to a half.
No.
Yeah, no.
Okay, we'll do it. We'll do it together. I just want to confirm that Artie's got the right answer for this.
Yeah, it's just taking a while searching.
Okay.
Because after I expanded, I then went down to the cos A cos B equals a half cos A minus B.
Yeah.
Plug that in.
Mm-hmm.
And then I had cos theta plus cos 3 theta minus cos theta minus cos 3 theta.
Okay, let's have a look.
Yeah, 1/2 out the front of all of that.
All right. Yeah, there we go. So let's have a look. So what you should have, so Artie, let me know once you found the answer.
Okay.
Right. So then what you should have is 3 theta becomes cosine 2 theta plus theta. Got it?
Yep.
So it becomes cosine 2 theta cosine theta minus sine 2 theta sine theta. Cameron, are you okay with that being the first line?
Yeah.
All right, the next line should become 2 cosine squared theta minus 1 cosine theta minus 2 sine theta cosine theta sine theta. Is everyone okay with that?
Somewhat.
Okay. Which bit are you stuck on?
You just pulled the 2 cosine squared theta
Minus 1. Where did that come from?
Yes.
Okay, it came from here.
Oh, right.
Got it?
Yeah, okay, that makes sense.
Yeah. And then sine 2 theta is 2 sine theta cosine theta from there. Yep. And then you got the sine theta and you got the cosine theta. Okay. So this now becomes cosine theta times 2 cosine squared theta is 3 cosine squared theta minus cosine theta
It's 2 cos cube theta.
minus 2, sorry, that's cube. Yes, that's right. Thank you.
And it's 2 still.
Yeah, it's 2. Yeah, there we go. And here you've got 2 sine squared theta cosine theta. You okay with that? Everyone? Cameron?
Yeah.
You okay with that?
Yeah.
You sure?
Yeah.
Okay, and then you got 2 cosine cube theta minus cosine theta minus 2. Now the sine squared theta becomes 1 minus cosine squared theta. Cosine theta. Is everyone okay with that? Cameron?
Yeah.
Good. And then now we go to cosine. cube theta minus cosine theta minus 2 cosine theta plus 2 cosine cube theta. Okay, minus makes a plus, minus and the 1 and the cos make a minus. That minus over here. Is everyone okay with that?
Yep, that's all okay.
Cameron?
Yeah.
Okay, and then you got the 2 cosine cube theta, and the 2 cosine cube theta is 4 cosine cube theta minus cosine theta minus 2 cosine theta is minus 3 cosine theta. Got it?
Yeah.
Mm-hmm.
So these ones, you need to be able to move through and get them really fluent. That one there.
Okay.
And that one there. Got it?
Yep.
Yeah. So just copy that down.
I found the answer for the
Yep.
question.
Yep. Was it right?
The answer says it's x minus in brackets 1 plus e y equals 0.
Okay, hold on. Cameron and Jackson, you copying it down still?
Yeah, I've got it down.
Okay, Cameron?
Not yet.
Okay, tell you what I'll do.
I'll send you the answer on Messenger.
Okay, yep. Oh, sorry, let me move this out of the way. Okay.
It should be there.
Okay.
Yeah, I've got it.
Okay, cool. Let me just go over here. What was the answer, Artie?
It's on Messenger. It's
Y equals to 1 plus E to the power, times X. Yeah, can you, hang on. I'll find it on Messenger. It just takes.
Yeah. It's almost what we've done, except they have 1 plus e and then a y multiplied with it.
Oh, okay. I think I know what they've done.
Okay.
Hang on. And then they've got 1 plus E times Y. And then what? Is that it?
Sorry. Oh no, they have they turned it into one of the other kinds of. They made it into an x minus in brackets 1 plus e close brackets y equals 0.
Might be the same thing. Hang on. Let me just find it. Mm-hmm. Oh, x equals to 1 plus e, y equals to 0.
Yeah.
Okay. So they've got Oh, x plus.
X minus.
Oh, it's a minus, is it?
Yep.
So let's have a think of how they might have gotten that. So
My guess is that he used x equals 1, and they used the other gradient, the 1 over 1 plus ex.
yeah. So hang on. Find the equation of the tangent to f inverse f minus 1 at p. Okay, cool. So p, we know is 1 plus e and 1. Is that right?
Yep.
Find the image p. Find the image p on... Oh, okay, right. So I think I know what they've done. Let me just try this out. Okay. So I'm just going to rub this out all together.
Okay.
So what they've done is they've said the coordinates of P are going to be 1 and 1 plus E, not what we have. And I'll explain why in a second.
Okay.
And the gradient is going to be what we had before. What was that? The gradient is going to be 1 plus e to the y.
Yep.
Or, hang on, no, it's not. Or another way of saying it is 1 over 1 plus e to the x, which is what we had before up here.
Yeah.
Got it?
Mm-hmm.
Then when we put that into the equation, we've got y equals to, oh, hang on, sorry. Y minus, now y1 is going to be 1 plus e.
Okay.
Equals to m, which is 1 over 1 plus e to the, and x is equal to 1,
Mm-hmm.
minus an x1, x minus an x1 is equal to 1. Got it?
Okay. Yeah.
So what they would have done is y, no, that doesn't make sense either, minus 1 plus e squared equals to, hang on, sorry. Just write this out. One plus e, y minus 1 plus e squared equals to x minus 1. I know what they've done, but for some reason it's not turning out that way.
Yeah.
So for some reason they want to use y1 equals to 1, and they want us to use x1 to be e1 plus e here. That's what they want us to use.
Right.
In which case you've got that happening, right? Those cancel out, and then you've got 1 plus e to the power of y equals to x. And then when you bring that across, you've got x minus 1 plus e, y equals to 0.
Okay.
So that's what they want us to do. Now, I don't know why.
Oh, I think I know. Because, like you said, the inverse derivative would be dx on dy. So if you wanted dy and dx, it'd be 1 over. So even if it's 1 plus e to the y, it'd still be 1 over 1 plus e to the y. And at that,
Yes,
y
that's
would
right.
be 1,
Yeah. So that's 1 plus e to the y.
which is 1, because
That's
y is
1.
1 in the... Yeah.
But y is... So then that would mean...
Because point P in the answer is 1 plus e and 1, which means y would be 1.
Oh, okay. Yep.
So then it would be 1 over 1 plus e to the y.
Is
and y is
still...
1.
Yep. So that point there is still 1 plus e. And that point there is still 1.
Yeah.
Okay. Whoops. Okay, so then x is equal to... No, see, that doesn't make sense. Oh, yes, it does. Yes, it does.
Okay.
Yeah. So then p is 1 plus e plus 1, so that's correct.
Sorry. Yeah.
Hang on.
Yeah.
Yep. And then f dash of x, which would be... So if you've got x equals to y plus e to the y, the derivative dx dy would be 1 plus e to the y, right?
Yeah. And then dy
That's the
dx would be 1
derivative.
over.
Sorry?
So then if we wanted dy dx, it would be 1 over. Because if we wanted it in the normal, like with y as a subject, we'd want to turn it into dy dx. Which is why it'd be 1 over.
Yes. Yeah. Absolutely. So then dy dx. Yeah, okay, that makes sense now. Is equal to 1 over 1 plus e to the y. Good. Yep.
Okay.
Which is the derivative of the inverse function.
Yeah.
Yep. Cool. And
Okay.
that's why it's equal to that, and that should be not an x. Yep.
All right.
So that goes in there. Yep. And then you've got y1 equals to 1, x1's equal to 1 plus e, and then, yeah, that should come out.
Okay.
Got it?
Yep. Thanks, Seung.
No worries. Okay. Where are we? Okay, cool. So we're right on 10 o'clock, right? Is everyone okay with where we left things today?
Yeah, that's all good.
Okay.
Yep.
What I need you guys to do, Jackson and Cameron, is can you guys send me your scope and sequence?
Sure, I've asked
Section
Miss.
1.
She said she's sending it to us in the next sort of 2 or 3 days.
Okay. Yeah, let me know as soon as you get it.
Yeah, we'll do.
Okay, and then the other thing I was going to say is the 2014 paper, right, will be due tonight. Okay, so please send that through.
Okay.
Yeah, and then I can mark it, see where you're at, and then we can take things from there.
Sure. That's the extension one, isn't it?
No, it's just the 2-unit one.
Yep. Okay, cool.
Yep. The extension one we'll kind of do once I get your scope and sequence.
Okay, sounds good.
Okay.